Hello, everybody, and welcome back to the number one podcast in AI engineering in Europe. This is the year. Throughout today, I did a quickly different introduction. I'm still in the Ibiza mode today, but we're talking about a few things in AI engineering today, such as the NVIDIA revenue, and we're also taking a hit on the newest models, such as Nano Banana. Welcome back on the show. Thanks for having me today on this Friday, shooting some AI engineering content. How are you, my friend?
I'm doing good. Not sure if the biggest podcast in Europe regarding AI, that's backed by actual numbers, but this is the world of AI, so we just ask GPT-5 later if he agrees. We do have some developments regarding new models. No major new LLMs so far. I think the GPU's on vacation somewhere, also in Ibiza, and the researchers, I think, too. But I think we're going to start seeing them again into September when business picks back up again. The companies want to be noticed in the market. So we won't be seeing GPT-6 for a while. I think they're still recovering from the hype crash. But then again, if OpenAI is not openly and aggressively hyping new models, other companies, I think they don't feel the need to also launch models every single week.
Exactly. But I think it's still a few things are happening over summer. So just to maybe quickly outline the episode today, last week, if you're interested, we talked specifically about AI security. We talked about cloud enclaves, the way you can actually securely run AI models in a, let's say, somewhat of a black box in a cloud. But today we take it a little bit one step further. Once again, we talk NVIDIA earnings very briefly at the beginning, what actually is happening on the financial corner of artificial intelligence. We talk about Nano Banana, a new image model, some sector I have been witnessing many different changes since I started in AI in 2023. We talk about quickly this famous MIT report that everybody was running away from AI, basically this 95%, let's say, non-utilizable AI projects based on MIT. It's a report that came out a few days ago. And also we talk very briefly, lastly, about human in the loop and what it really means to maybe be engineering AI in the future, small language models versus large language models, and maybe that we humans are the signal to AI and not the other way around. But let's maybe kick it off with the NVIDIA earnings. They came in probably more or less the way we expected them, fairly strongly. Just to wrap up a few of the numbers, just for you, the audience, I can maybe quickly display these infamous charts, the flow ones that actually are more or less seeing where is really the revenue coming from. Of course, with NVIDIA's data centers, they're still on the game. Joao, even in summer, it's hot. The chips are producing many tokens. The revenue is up 56% year over year, and it reached a staggering multiple billion again. I mean, it's pretty impressive the way NVIDIA is performing, but I don't think there's anything new to unpack here other than the margin is pretty high still, and we are seeing pretty much a dominant position from NVIDIA. Many of my kind of close circle friends are saying AMD is on the run up, but let's see about that in the future. There is also something worth mentioning, these H20s. I think they were excluded. There is some considerations in the politics going on, especially shipping lower tier chips to China. And also in the future, there might be a Blackwell chip that might be downgraded from the ones we get in the West to be shipped to China. And I think these particular numbers, as mentioned by the CFO, they are not entirely baked into the financial statements. But yeah, quick comment from you, Joao, before we talk about Nano Banana.
I mean, regardless of all the political and geopolitical warfare that's going on, you're going to have Chinese chips pretty soon. I mean, you're telling the biggest manufacturer in the world, the biggest electronics manufacturer in the world, the country that has been surpassing all expectations in terms of economic development, saying you can have these chips that we made. I mean, I think the obvious answer will be that they'll make their own ones, and maybe it won't be as good in the beginning. But if they can make them in house, they can make them for cheap. They're gonna make a whole lot of them, and so I foresee some trouble in the, let's say, medium future for NVIDIA. You can make chips overnight. It's a hard process. You have to have a lot of factories, a lot of research. But NVIDIA has a lead, and as a software developer, as an AI engineer, I've worked in machine learning and I was doing CUDA core development. NVIDIA has this kind of monopoly on the market that for researching, for GPU processing, you're always using this CUDA core frameworks for CUDA processing, which is a very NVIDIA kind of thing. They only work on NVIDIA GPUs. And there are open source alternatives, but they're nowhere nearly as widely adopted. And so if NVIDIA keeps pushing the market, if the prices for NVIDIA GPUs have been higher than what AMD sells their GPUs for, so they're already pricing in that kind of dominance over the market. And people will start to bet more and more on the open source frameworks or this alternative to the CUDA and the NVIDIA ecosystem. And so I think NVIDIA is a really big company. I think they're holding the market together. But AI might not need to run on NVIDIA alone. So
a bold statement. Into the direction of Grok and, for example, AMD as well. Of course, just from a general understanding, AI chips is not the only one that's actually powering the token production. We have the rack-to-rack communication. We have many high bandwidth memory considerations and so on and so forth. So just the chips itself are not powering AI. It's really these intercomplex systems that are really running into the data centers that are actually powering today's large language models. But I think it's still a reconfirmation that we might be on a great trajectory for the future, but maybe not year-to-year growth potential that is left in the pipeline for NVIDIA. If that continues in 2026, 2027, I'm still super bullish without financial advice. It's still a big chunk of
legally,
my portfolio.
Not financial advice.
Exactly. But I probably also start looking at maybe early 2026 into how I would weight NVIDIA in my portfolio, as opposed to, again, high bandwidth memory producers, interlink communication producers, for example, the machines to actually build chips producers, and so on and so forth. So this is something I probably have to be checking on my portfolio maybe later in this particular year. But let's quickly talk about Nano Banana, the newest model by Google. Joao, you gave it not a different name, but what's the actual technical name? Nano Banana, I think, was just a marketing gig, I guess.
I mean, it is a very marketable name. It's a funny name. But Google also calls it Gemini 2.5 Flash image because they already have a 2.5 Pro, 2.5 Flash. So 2.5 Flash image is, let's say, the full legal name of Nano Banana. Nano Banana is the nickname for the ads. And it's pretty good. We said no new models in the beginning of the episode, but no new LLMs. So this is a text-to-image model.
New language models.
No new language models.
So you're all
there's new image models, and it is pretty good. And I think people are already pretty excited and using a lot of GPT-5 images. You see them a lot on LinkedIn, on ads, on TV. You're going to be seeing a whole lot more of them. I mean, this is cheaper than paying a designer. But I think if they're getting good enough, you're gonna have new kinds of MVPs, new kinds of startups, and new ways of using them. One way that I was seeing a couple hours ago was someone using it to decorate their house. So they could take a picture of their house, give it the image to the model, and say, add a shelf, paint a wall, move the couch. Like, you can give those instructions without having actually to paint your house. It takes a bit longer than prompting the model. And you could do it in the past, of course, but if you put it on GPT-5, for example, the image is going to be a bit off. I mean, the colors change a bit. Everything gets a bit of cartoonish makeover. And 2.5 Flash image, or Nano Banana for our young viewers, it is remarkably accurate. I mean, you can take a picture of your house, say it to add something or take something off or add a new wall, and it will sound realistic. It won't zoom in on the image or reformat it, and you can just work with it. And I think there are going to be a whole lot more applications where you can have that kind of image segmentation and image generation based on previous images. I think Pinterest already has like the feature you can get a bunch of images together, but I think it's more of a collage feel. And if you add AI to it, and they will be adding AI in the near future, I bet, you can have a whole lot more different kinds of usages for Pinterest, and I think other startups that may appear.
I think it's an interesting way of maybe looking at the use case. Just from my own personal context, when we started in 2023 with image models, that was on the stable diffusion algorithms. We had two particular use cases we wanted to charge money. The professional portrait use case that's still working today and is still generating revenue, basically, Europe. But also we had a different other use case, which was the interior design use case. Back then, as you perfectly pointed out, that was before the language models actually had image capability. We tried stable diffusion, even the Black Forest Lab models as well, or stability AIs at the very beginning, and it just didn't really get the architecture components correctly. So especially room modeling, 3D space modeling, was somewhat reaching a limit as opposed to human face modeling. That was kind of okay. So I still maybe can put it on the screen here. That was literally 2023. I think probably in May or June, my post-production person is probably telling me this is wrong. That's what I had it in mind. Spring 2023, when we were trying to prototype and launch not only formal frame, but also some sort of interior frame using stable diffusion. And probably what is now 2 years later now, we have Nano Banana finally being able to do that to a better extent, hopefully, than GPT-5 and Stable Diffusion. I think it just shows that, yes, we are progressing, but sometimes, especially in image generation, where us humans, we have this particular eye of something is off in a room or something has been moved because we live in these spaces 24/7. It still took some time to actually be getting that correctly. I still have to validate maybe quickly on Nano Banana how good it really is. I think we still have the test set from back then based on many rooms that we were using for our testing pipeline. Maybe we can just quickly fire that through and see how it compares. Maybe in a future episode, I can quickly do a quick legacy comparison, old Stable Diffusion on Stability AI or Black Forest Labs, as opposed to today, Google also taking on these use cases. I think for architecture use cases, especially interior designs, if you have a new house that you don't know how it looks like, I think it's phenomenal. You don't have to hire the professionals. Yet again, AI took away a job, Joao. We're already at this stage.
I'm trying to avoid creating a drinking game out of the podcast where people have to drink every time I say I foresee a future. But I foresee a future where, because we have this housing market crisis, and because we have a model that is apparently quite good at decorating houses and creating images of interiors of houses, that we're going to be seeing a whole lot of fake ads for houses and a whole lot of scams that are based on these ads for houses. Because people ask for new pictures, you can just generate more pictures. They sound just right. Maybe you can make them a bit unclean if you're not trying to sell the new house, your fake new house. Maybe you want to sell a fake secondhand house. And I foresee a future where this scam is very likely and very profitable, especially because people are not used to AI images.
Yeah, maybe. I mean, it's potentially a good use case. I just thought for private use case.
A good use case, Cyril? I think that the scam is a good use case.
Cool. It's a criminal use case. I don't want to incriminate myself. But all things that are somewhat real and reality similar, I think it's a great, achievement for AI, even if it's criminally used. I'll probably have to correct myself here. It's not a good use case, but it's an interesting use case. Let's quickly maybe shift gear into this MIT report. I don't think we need to spend much time on it, but there was a report that came out a few days ago from MIT, I think the best technical university in the world, saying that a significant amount of projects, I think that the number really was 95% of AI or Gen AI related projects do not yield a positive ROI within a few months. I think the notion was six or so months, which is an early probably time frame to actually be judging a new innovative project. Still, that came out. And I think from the back burner of that particular report, many people again got a bit worried about AI, how usable it is, and if that's really just a bubble yet again, as we saw in the .com. I just want to quickly hear your feedback, Joao. I also have my kind of read to these reports usually, but what's your take? Is that somewhat accurate, what you hear and see, or it's a bit brutal?
I don't doubt the numbers that the report states. I do think that a lot of ventures and a lot of startups in AI could fail and build projects that cost a lot more than they're giving back. I'm a builder, and I've built a whole lot of these kinds of projects and a lot of different kinds of projects. And I have an idea of why this is happening. And I think if a new technology comes up in 5 years, it'll keep happening. But I mean, do you want me to tell you why I think it is? Like, why I think most companies fail? For the audience that's just listening to this, he's nodding his head. It's complicated. People are used to this idea that you could build Facebook in a couple of weeks, like Zuckerberg did it in 2008 or 2000 something. Maybe that back then, like you had things were just simpler, right? Like you had less components. If you want to launch a website, you start a server, you put some HTML on it, you had a website. And nowadays, if you have a website, the expectation for a website is a whole lot bigger. It has to look good, it has to have contact pages, it has to respect GDPR. There's a whole the stakes are higher. So the website that you're launching, unless you're launching a very shitty website, it has more components, it has more complex flows. It's just harder to build. And this is just for like simple click and see websites. If you're building RAG software, the concept of it is pretty simple. I mean, you can build demos with it in a week, maybe 2, if you have somewhat experience in building software. But to make it production ready, to make it something you can actually sell, you can build people for it, that you can sell to companies, make it stable and get the answers you want, you have to have like a lot of different complex components to it. So caching, database, this control of the flow of LLM, which is not something that you can predict what it'll be. So you can run the same tests twice and get different results. And there's ways to handle this, but it's not easy for people who don't have experience, right? So you're going to be start seeing like there's a big difference from people who experience and build things and are like senior at this and people who know how to code but never build something with GenAI. I think that gap right now matters a whole lot because it'll be the difference between building something that works, that gives you money, or building a toy that'll break in a few days, or if you just press the wrong button. I think companies underestimated how quickly they could build it. And so, of course, like the report, I think, has a really short time window for this kind of things, but it makes sense. Most companies, I see a lot of job ads for this kind of jobs. Like recruiters keep reaching out to me, asking me to join their companies. And even the job ad, I can see like they're mentioning fine-tuning models, and they mention what the project is. And I tell them, I know you're from HR and you're not going to be involved in the project itself, but please tell someone fine-tuning or like these things that you're mentioning in a job ad, they're not at all related to what you want. And so there's this difference and this gap between what is actually needed and what companies are building. And for what, I mean, they'll get there. I think next year they'll be better. But this year, like this is a year to build stuff. This is a year to fail at build stuff. I think it's good that some companies got it right, but it makes sense that most of them didn't.
That was a brutal statement, but thanks for your honest opinion. I think I also have a few maybe just conceptual vectors to throw at this report. I mean, the first point, I mean, it's just common kind of understanding that AI is a probabilistic system, meaning not each and every single output is somewhat, 100% accurate all the time. There is a probability distribution under these outputs. It might be something that's 90% accurate, something it's 97%, 99.5, 99.9. But simply the way these systems are built, again, in a probabilistic way, I think it's just very difficult to map a 100% correct answer at any given moment. I think for a particular business value to be created, I think many of these softwares that just have to have these high thresholds of 97, 99, or 99.9% accuracy. And we might not have the tool set yet to be building these systems at the end of the day for all the use cases at 100% or close to 100% correctness. Not necessarily saying that all of these models are hallucinate as much as I did before. I think they are getting better by itself, but we need a lot of human ingenuity to be actually adding this particular nuance to get it from 90% correct, maybe out of the box, GPT-5, for example, to then 99.9% correct. Brings me maybe to the second vector I would throw at the report, which is human in the loop. I think many of the systems that we were portraying at the beginning of the year just had the outline that AI will do all the jobs, all the part of the workflow,
humans altogether.
Replace humans altogether. And I think the more I think about it, the more I see the way these systems are working, the less I think that is true. So I think we do need human in the loop, especially maybe to fact check particular aspects while the AI does most of the heavy lifting, but also maybe trigger the AI to go then again do the workloads and then come back. So we maybe as humans, we are getting more as the code reviewers, the output reviewers, as opposed to doing the heavy lifting ourselves, as opposed to the AI system doing everything. So that's maybe the second notion. Again, first notion is just the nature of probabilistic systems, that they are inherently not 100% factual correct all the time. So we need to wrap our head around it and maybe couple it with other types of software that are super correct, more deterministic, and also the human in the loop aspect. And maybe the third one, I think no company was ready in terms of data availability last year for AI systems. So that's maybe the third vector I would throw at the report. We're trying to build a super intelligent system that should be using data that's not even available in the organization. So many of the companies that I talk to, that I see, they don't have data mesh, they don't have data owners, they don't have data availability, they have no clear structure of how the AI can actually access the different types of signals you have in a company, aka the data. So how do you want to make great systems? So it's kind of all siloed anyway. So that's maybe the second, or where am I now? The third one? The fourth one is, exactly. The fourth one is probably security. That's a problem we can solve in the cloud. And then the last one maybe is the context in general. Once we have great data and we actually understand how to do great context engineering, shout out to maybe quickly another video we did also on context engineering. I think the better these systems are becoming, it's all a compounding function. So we have to do that all together, right, all the time. So I think that's why it's inherently difficult. But I think we do get there. I'm still fairly hopeful. Or did you give up hope, Joel?
We will. I haven't given up. I think it's the same. It's the same effect that you're really hungry, going to a restaurant, and you order too much food. You just businesses and CEOs wanted to replace people so much because I get that the human labor is expensive. that they really wanted to replace people. And they built these systems and they ordered the systems to be built by their IT teams. And of course they fail because I don't think the technology is at the point where you can build something to reliably replace someone altogether. I mean, the goal for the systems right now is to augment. You've heard this, I mean, maybe before 2020, you never heard this word, or you heard this word like once a month, and now you'll hear it 4 times a week or a day. But these systems are supposed to augment people. It's the same reason, and I'll give a very practical example. GPT-5 and Claude 4 Sonnet or Claude 4 Opus, they're very similar models. And they have, in terms of coding, they're very similar benchmarks. So they should be about the same. However, to me, GPT-5 is, I won't say trash, but to me it's half as useful as Claude 4. And in the benchmarks, they have the same exact, almost the same exact score. I think GPT-5 is even above it. Why that is because if I ask Claude 4 to build something, it'll go through, it'll explain to me what it's building in real time. It'll ask me things if it wants to change something. I'll give some input if it doesn't know what it needs to run, and it'll walk me through its entire process. So I can read what's happening, I can change it and give it input on, actually I want something different, and I have the exact result I want, twice as fast as if I was the one building it, or at least 5 times as fast if it's a big piece of code. I mean, I type fast, but not as fast as an LLM writes. GPT-5, given the exact same task, exact same prompt, it'll be silent for a while, then it'll write the code. It's a one-shot thing. And I mean, for people who want to build one-shot things and for people who don't know how to code, maybe that's enough for them. But to me, I need to have some access to what it's building because most of the times it's going to be slightly off from what I actually want. So I have to readjust it and reprompt it. And I can do that with Claude 4. I cannot do it with GPT-5. The same thing we talk about humans in the loop. If you build a system that you have high observability of what's happening, AI is still doing things. AI is still using tools and getting information and writing your emails and scheduling your calendar. But if you give people the chance to see what's happening, change it and confirm or cancel these actions, it's still a lot faster than doing it manually. And it's still a whole lot better to use than trying to do it all automatically. And then you end up with something like 2 new meetings or 2 new events in a calendar that you didn't want. Something like a wrong answer somewhere. So this transparency and having people be part of the loop of the AI is a necessary step. Maybe in the future the AI will be like so much better you won't need it or you won't want it. But for now, and I think for the next year at least, you're gonna have to have it. So I think it's a major difference between what AIs made it and what AI companies didn't.
I think it's, perfectly agree with that. I think it's just if I had to paint the picture of a future, or at least say this is probably what's going to happen, we need observability on the model. We need to probably have some sort of, again, it's an iterative way of how we work with these models. I quickly checked today, or I can maybe quickly do it live on my phone now. What's the screen time on ChatGPT, at least here? It's a few hours a week. Yeah, it's still a few hours a week. It's like 5 or 6 hours on my phone, and then at least a few more hours on the laptop. So I'm literally anything I'm doing on a day-to-day, be it research, building slides, building sales pitch decks, building software itself, I'm just constantly using it. And the way I use it is not just do it once and then I go do something else. So a one-shot explanation, as you said, it's mostly an interactive way. It goes off, does something, I readjust, it goes off again, use the 3rd or the 4th output, but it's an interactive way of how I work with AI. I think it's really this human in the loop thing that I was mentioning before that probably will be working as opposed to this one-shot artificial intelligence. And maybe the last concept I quickly mentioned is the small language models. We're only talking about NVIDIA's chips building large language models and everybody's using LLMs. But there's also this concept of small language models that might be super targeted at particular use case. For example, in finance, in law, in health, in medicine, that are then across the benchmark really be outperforming GPT-5 or a Claude or a Gemini or whatnot, some other models. So I think this is probably also what could be happening in the future. So we have a core intelligence in our systems, and then we have SMLs, small language, SLMs, that we can then trigger, or the core intelligence can then trigger, and they go off and they have their own tools and they report back. So this kind of structure I see happening as well. I think that's something that's probably not 100% there yet. We quickly talked about this before, Schwau, open source finance models, open source law models, simply for the stuff we are actually using it. And there's not many around yet, but that's certainly something that could be happening into the future. Again, we combine humans with large language models and humans with small language models. And also there is an interactive loop between all these 3 participants. in doing AI that is maybe more than 95% non-usable in a 6-month period. Let's see. That's my forecast.
I think the first red flag we saw, I think it still happened within this year, or it was at the end of the last year, which was Devin. Devin was supposed to be the AI agent that could code whatever you wanted it to be. And he could access your Git repository, could write code for you, could deploy it for you. It was supposed to replace the full stack engineer altogether. And he didn't, and he failed, and you never hear about it anymore, because I think either they went bankrupt or just they're scaling down their businesses. And it makes sense. Again, it kind of loops back to you can't replace people altogether. This is not a question of whether AI writes good code. It does. It's writing increasingly better code than most people. And I think it'll get to a point where it's writing the same level of code as senior engineers. But if you try to automate some flows, you'll achieve something. If you try to automate an entire job worth in a single project, in a single shot, that's, I think, too ambitious of a goal to have. Unless you have like 1,000 developers at your disposal.
I just believe like one of the coding use cases I think maybe businesses haven't yet have a look at is really this refactoring of old code. And that's certainly something that's super annoying as a dev. But that's maybe something that AI can really be helping to actually do the heavy lifting. In banking, I mean, I remember the days there was COBOL, not happening today, hopefully in many banks, but still. And if you have maybe 2 devs left in your firm knowing the code base of an old software domain in a bank, that's kind of problematic. But maybe AI can help do the heavy lifting. The reason why I bring this up, I think many code bases today might not be, this is hypothetically true or not true, I don't know, we will see. It's not set up in the best, because you actually assume that's the way we set up a large code base, for example, at a bank, for example, the card system, the trading system, the account management system, whatever you name it at the bank. It might actually not be the best and most suitable way for an AI to be well performing in this particular code base. I think we humans, maybe we have a different way of architecting code base as opposed to the AI. Maybe we lose less substructure, more substructure, whatever it might be. I think that's something to be defined in research maybe as well. What's really the best way of structuring a software product or software project in general for it then to be maximally leveraging artificial intelligence? Because currently we just would assume that the current ones we human built manually over the last decades might actually be the best for AI, but that could also not be true. So once we use AI to refactor, it maybe creates its own best structures. It might be a better servant as a coding agent. That's just my hypothesis. I don't know what you think, Joao. Is that completely out of the window? Or that might actually be something that's happening?
I mean, maybe it doesn't have to reinvent the wheel, but there are certain patterns in code that makes it a whole lot easier to read, especially for us humans. If they're writing it from scratch, it's likely that they're going to repeat the same patterns that we did, especially the better patterns, if they have a way to distinguish between good and bad code. I think eventually, if we give AIs enough time to write and train on their own code, you're going to have new patterns pretty soon, where things connect in a way that's better for the context and the way that they see code. I hope it's compatible with the way we see it, because I like to work in collaboration with these models, not in competition. It always goes bad when you're trying to compete with the technology. But the bar for writing code and for writing big production code bases is not that high. You have really old legacy systems that work. They do what they're supposed to, but they were hammered for 10, 15, 20 years until they worked right. And so they're weird and complex code bases that they're really hard to work on. They're really hard to add new features to. And if you can have an idea on how to rewrite them and how to refactor them into modern technology, so you can run them for cheaper, you can run them easier and faster, and can have lower response times, you're going to have a really good return on investment on that particular project. But then again, you have to have someone, not just AI itself, have someone with the AI to make it happen.
So maybe quick suggestion for our next MIT report and the companies do some sort of a code refactoring projects and hopefully yield a better return on investment, because currently probably no human wants to do actually that work of refactoring. Great. Any last comments from your side, Joao, before we wrap up this episode, which was a bit of a mix between a few things, but anything else?
We're seeing a couple new features, a couple new models. We mentioned the Nano Banana. We didn't mention Mirage 2. Because it's pretty similar to the Genie 3 model we talked about last episode. If you want to go see about it, go check last episode from the podcast. Basically, it's a model capable of creating a world for you. You can have your own character, walk around in it. It seems pretty fun. Can I run it on my computer? Can I game on it? Not yet. hopefully in the near future, especially with cloud gaming, so some beefy GPU somewhere is running that model and I can just use it on my computer, that'll be fun. I think maybe in a couple of years, we're going to have something that you can run locally. Maybe you're going to be seeing a whole new kind of games where you can change the map, change the rules whenever you want. I'm excited for it. But I think the tech is still a bit new to see products from it. So there's really not a big reason to mention it just yet. But maybe in a 5 to 6 episodes in a podcast, he'll see us talking about a brand new product, a brand new feature that's going to change the world.
And even though, I mean, I'm currently sitting in a spaceship, or at least that should mimic it, but we're only in this journey for around 3 years in AI. And I think if we beam ourselves into the future 3 years from now, given that it's on the linear growth, I think all these problems that we talked today, once again, human in the loop, small language models, security, data availability, and maybe some sort of new ways of computing them, maybe a new transformer architecture, probably will solve all of these problems. So the ratio of 95% failing and 5% making it hopefully will be switched to a 95% making it into production with a positive ROI. I'm still very positive. It's still the year to build. That's why this podcast is called This is the Year. For all the subscribers are already out there, we're shooting these episodes every single week. If you're not a subscriber yet, please feel free to drop a sub and add a comment if you have a question or something we should be covering. Also, I'm fairly responsive on LinkedIn, and a few of you reached out to me for some new suggestions, for example, security last week, and also for small language models that we covered today. These came through LinkedIn. Feel free to drop me a message or to Joshua, and we are happy to do these next episodes already.
Drop me a message, I'll just resend it to Cyril.
For the organization. Exactly. Great. Thank you, Joshua, for joining. Have a good weekend, and I see you in the next one. Take care.
See you next week.
Bye-bye.